Hey everybody, this is Mr. Longo here, and this video is going to go over how you draw conclusions and use the chain rule. So drawing conclusions is something where you're given some information and you just say, hey, I can draw this conclusion. So for an example, if you live in Gurnee, then you live in Illinois. So Bob lives in Gurnee. What conclusion can you draw from that? Your conclusion would be that Bob lives in Illinois. I mean, Gurnee is in Illinois, and therefore, if he lives in Gurnee, he has to live in Illinois. But you can't always draw a conclusion because there are ways to prove counterexamples as well. So in this next statement, it's going to say that if you go to Warren Township High School, then you are a teenager. Joe is a teenager. So what conclusion can you draw from that? Well, none. Joe is a teenager. Maybe he goes to a different high school. Maybe he goes to a high school in California. Maybe Joe goes to a high school that is in another city. Just because Joe is a teenager doesn't mean that he goes to Warren Township High School. And it's because of the order of which was said. So the first one said, if you live in Gurnee, then you live in Illinois. That is your if-then statement. Living in Gurnee is your hypothesis, and you live in Illinois is your conclusion. So then if Bob lives in the hypothesis, then he has to live in the conclusion. But remember, the converse is not always true. So this one went if-then, and then it went then-if. So it did the conclusion, then the hypothesis. And remember, that does not always work. And then sometimes there's one that leads to the other. So if you take good notes and study, then you will learn. If you learn, then you will pass the quiz tomorrow. So really, you can sum that entire thing up as if you take good notes, or take notes and learn and study, then you will pass the quiz tomorrow. So sometimes conclusions can be drawn when there's multiple steps. And basically what happened is we took a hypothesis and a conclusion, turned the conclusion into the hypothesis, and came up with a new conclusion. So these two kind of cancel themselves out. So if you take notes and study, then you will pass the quiz tomorrow. Okay, so that is pretty much how you draw conclusions. You have to make sure everything comes in the right order. So we're going to take that a step further and go to chain rule. So chain rule is where you have something like A implies B, but B also implies C. C also implies D. So if you think about it in terms of the last example, A implies D. Through B and C, of course, but the beginning and the end is going to be A implies D. So you have to remember one other thing. When we learned about conditional statements, the contrapositive is also true if the conditional is true. Well, if I say that A implies B, or if A then B, you can't tell me that that's false because this is just a chain rule. However, if the conditional is true, then the contrapositive is also true. So if you have something that doesn't match, sometimes you need to switch them around. Okay? So let's do the next one. This is where the contrapositive is going to come into play. So just like this example, we have a B on the right and left. We have a C on the right and left. And after we cancel them, we had A implies D. But over here we have not B's, but we do not have a not C on the left. We actually have a C on the right. So what you're going to need to do is just rearrange this one statement. So what you want to do is use the contrapositive, and you want to rewrite it as not C implies not D. Okay, and all we did was rewrite that statement as a contrapositive. And now watch what happens. We're going to have our not B's cancel, our not C's cancel, and we are left with A implies not D. So the contrapositive can be useful when using the chain rule. Okay? So, I did 2 examples. Why don't you pause the video and try number 3 and click play when you're ready, and then you'll have the opportunity to try number 4, which is a little bit crazier than the others. So go ahead and pause the video, click play when you're ready to see number 3. Okay, so we have an A and a not A. So we're going to have to switch one of those guys around. We also have an X and a not X. So they're on different sides. However, if we switch just this bottom one, we will rearrange the A and the X, and this will be easier to do. So we're going to take the contrapositive of this statement. So we have to switch and negate. So this becomes not X implies A. And now that guy is gone. And now we can do our canceling. Our A's cancel here. Our not X's cancel here. And we are left with M implies not B. Now I want to let you know that if you switched yours a different way and came up with B implies not M, you are also correct. Because remember, the contrapositive is going to be true if the conditional is true. So again, pause the video and try number 4, and that'll be our last example. Okay, so first of all, I'm going to show you a sneaky little shortcut here. We have R's on the same side, but I'm going to just cancel them really quick. And then we have K's on opposite sides, so that guy's good. And then we have B's on opposite sides, so that guy is good. So really, what I just did is show you a little shortcut to these. You have not C on the left, but J on the left as well. So you just have to move J to the other side, or move C to the other side. So since the K's were already canceled on opposite sides, the only ones that weren't, or the R, those were on the same side. So you would just switch and change this to J implies C. And all I did was move this to the other side. But even if you did it the other way, you could still say not C implies not J and move J to the other side. It doesn't matter. But if you just cancel the letters that you have, that's the little shortcut. Okay? But if you came up with either one of those, you are good to go. This is Longo and I'm out. See you, bye.